the comforts of your home. It should be a more enthusiastic yes, sir.
Yes,
You should
sir.
be shouting. I hope all of you are fine. Nobody is sick. Nobody has tested. Anybody got tested because of something? No one. Good. So we will start the class. Let the others come in. We will start by recapitulating that we defined epidemiology in the last class. It's a very, very important definition of John M. Last and McMahon and Pugh. Okay, you need not remember the authors of this definition, but you must remember the definition. Then we talked about the tools of epidemiology. We talked about the measurements, which was in fact to repeat, because measurements are nothing but indicators. In measurements in health, we are only measuring some indicators. We are only comparing. And then we came down to the heart of this chapter, which is the way we describe the various types of epidemiological studies, observational and experimental. In observational, we had descriptive, and today we are going to talk about analytical. This is a very, very important classification. Please remember it. Write it 10 times, like our teacher used to tell us, write this spelling 10 times, and then only you will remember. Because a simple thing like define epidemiology and define the various types of epidemiological studies or classify epidemiological studies, many of you cannot do. And if you can do it, you can get 2 plus 3, 5 out of 5. The rest part of the question, you may get a 4. So you get a 9 out of 10 in a long question. So we described we described the descriptive epidemiology, which is nothing but a cross-sectional study. I gave you the example of the ICMR study that you people do. You go to a classroom, take a survey, it's a one-time thing. Whereas in analytical, though it is observational, we have to analyze a little bit more. So therefore, please remember observational, descriptive, analytical. Okay? And here we are with analytical studies. Why is it not responding? Yeah. The second major type of epidemiological study in descriptive epidemiology is called as in observational epidemiology is called as analytical epidemiology. Now, this is basically testing a specific hypothesis. You know that certain thing may cause something, but you are testing it. You are verifying it, right? Please get your fundas right. There is nothing very, very difficult in understanding. You must know that analytical epidemiology basically deals with testing hypothesis. All analytical studies must begin with a clearly formulated hypothesis. You have a hypothesis, you know that cigarette smoking is bad for health. But can you prove it? You have to prove it by an analytical study. Okay? It must be quantitative and specific and must predict the relationship of a risk factor to a disease. I told you, I gave you the example of cigarette smoking and lung carcinoma or other things or respiratory problems. It should be quantitative, specific, and must predict the relationship of the risk factor that is smoking to a disease. Okay? Here, the subject of interest is the individual within the population and not the entire population. Though we differentiated between clinical and epidemiological workers, we said that clinical deals with individuals and epidemiology deals with the community. But here, we are testing the hypothesis on individuals and finally extrapolating it to the community. Whereas in a community survey or a descriptive epidemiology, we went to the community one time and took a survey. Okay? So slightly difficult because I'm going a little fast, but as you read the book, things will become a little clear. I am only helping you a little bit in understanding or getting familiarized with these terminologies. Okay? But at the end of the study, the conclusion or inference is for the whole population. You must get that. Though the individuals are the subject of interest, we extrapolate the study to the whole population. And there are two distinct types, case control and cohort. These words should be breathed in and breathed out till the time you people pass out your MBBS and maybe MD, because you will be either doing a case control or a cohort study in your MD. From each of these, one can determine whether there is a statistical association. Now, association may be sounding like an English word, but we will define it later. Okay? Whether or not a statistical association exists between the disease and the risk factor. So if I do a study, I'll please understand, I'll find out whether there is a relation between smoking and cancer. So relation, association. And if the association has been proved, how strong is it? Is it very strong? Is it average? Is it poor? If you smoke 20 cigarettes a day, you may get lung cancer. Or is it that if you smoke 20 cigarettes a day, you will get lung cancer? Okay? So strength. So remember the words which have been highlighted in yellow. First of all, we have to find out the association, and secondly, the strength. Okay, how strong the association is. We will quickly go on to case control studies. Remember, there are two words here, case and control. Now, this is an analytical and comparative method of observational nature to test the causal hypothesis. Whenever you are given a question, describe case control studies, never start with the description of the study. Most of you do that. Define. Whatever definition comes to your mind, you define. It's an observational analytical study where we compare cases and controls. See, I'm just giving you my own definition. And we test a hypothesis, something of that sort. You write a definition and then you start. Okay, what is the aim or purpose of case control study? I told you these things already in the last slide. To establish a causal association and its strength, I told you this, it's a repeat. Both cases and controls must be comparable with respect to known confounding factors. Confounding factors can be a short note. I'll describe it in a little more detail later on. So therefore, when I compare, I cannot compare your class with Final MBBS Part 2. I cannot compare your class with second MBBS people. You have to be same. You have to be of the same semester, same age group, same batch. Okay? So therefore, cases and controls must be from the same batch. They should be equated. It is not that tomorrow you come and say, sir, my team was very weak, his team was very strong. You put all the good players in his team and you gave me all the weak players. That's why I lost. So to have a good contest or an equal contest, we must have both the teams almost equal. Okay? So therefore, cases and controls must be comparable. This is a very, very important thing that you must know. That's why I am repeating this by giving you examples of two teams which are playing against each other. If you don't balance the teams properly, the cases and the controls, then your study will be biased. Okay? Because of certain confounding factors in one of the teams. And in this example which I gave you, confounding factor is that there are more good players in one team. So therefore, the team is not balanced. Or you can say there are younger players in one team who are more energetic, who are more enthusiastic. Okay, and there are older players in the other team. So you got to match the age, you got to match their expertise. And if you don't match, these become confounding factors. Ladies and gentlemen, please remember these words, confounding factors and bias. They are very important as far as epidemiology is concerned, and they are both potential short notes. Now, distinct features of case control study. Both exposure and outcome have occurred before the start of the study. The study proceeds backwards from effect to cause. God forbid, if somebody has COVID positive and he's asymptomatic, what we are doing is we are tracing back. Where did you go? Which restaurant did you visit? Whom did you meet? Who are the people in your house? Anybody tested positive? So we are going backwards in history. What we are doing is we are doing a retrospective tracing. Okay? So therefore, case control studies are retrospective. The study proceeds from effect to cause. Remember that. It uses a control or comparison group. That is, of course, I already told you, cases and controls. Cases are the people where you find out what happened to them. and by going back, and controls are the people who are the comparison group. This is the diagram given in your book. See, the cancer patients have already happened. Okay, there are already cancer patients. So we will take their histories and go back and therefore compare the histories. We take the comparison group of non-patients, patients who are comparable in other aspects other than cancer, and we take their histories and go back. Cases and controls retrospective study. Please remember this. Draw this diagram in the exam. Many of you don't draw diagrams in the exam. A thing which I already stressed once. You must draw a diagram, and all those 20 lines that you have written, they become clear if you draw a correct diagram. The basic steps in case control studies are four: selection of cases and controls, matching them, measurement of exposure, analysis and interpretation. The last two are almost the same or the same as any other study. Whenever you do a study, you collect data, that is what is measurement of exposure, and you analyze the data and you interpret. The same thing happened with descriptive studies. Now, what is important is how you select the cases, how you select the controls. I already told you, and you match them. It is like matching, this color of my shirt with my pant or whatever. I want to wear a matching dress. When we were children, we used to wear matching dresses. So it has to be matched. The cases and controls after selection have to be matched. So you've learned a third important word after bias and confounding is matching. They are almost similar, except that the way you write your answer. Matching is also a potential short note. Selection of cases, you have to define the case. I already told you we have to define the criteria in the descriptive study. What is the disease that you are going to study? You have to set specific parameters. A person with high BP of more than 140 millimeter of mercury systolic and 90 millimeters diastolic, aged 50 years and above, with no other comorbidity, will be the person who will be selected for the study. So you have defined. Similarly, you have to define the case, okay? And you have to mark eligibility criteria. Only newly diagnosed or incident cases within a specific period of time are eligible, rather than old cases in advanced stages. So you have defined the cases. You have selected the cases and you have defined them. How do you select the cases? Either from our hospital, okay, or from the general population. So there's nothing great here. So when you write the first step of case control studies, selection of cases and controls, what is more important is how you define the case and what are the eligibility criteria of incident cases. Selection of controls, similarly, you have to have a comparison group. I gave you the diagram of cancer and non-cancer patients. Okay, so if I go to the population and select cancer patients, say we will stick with the example of lung cancer, we will also have to select people who smoke but don't have lung cancer. Are you getting me? Smoking is not supposed to be a confounding factor. You have lung cancer cases and no lung cancer cases, but the other criteria should remain the same. That's where you define the case. That is why definition is so important. Control should come from the same source population as cases, preferably. Suppose I have gone to the hospital and selected cases, I should get the controls also from hospital. A comparison group is identified before the study is done, comprising of persons who have some factor whose influence is being studied. Okay? Difficulties may be there in selection of controls if the disease is in subclinical form and therefore difficult to diagnose. Okay? So you have to be very careful if the disease like COVID is in subclinical form. I just gave you the example of asymptomatic COVID patients. Controls are free from the disease but similar to cases in all other respects. I am repeating it. I have repeated it perhaps the 10th time today. Controls are free from disease but similar to cases in all other aspects. Appreciate this point. Remember this point. If you in future do studies, always remember to match. Failure to select comparable controls introduces bias in results and decrease the confidence one can place in the findings. Many a time when we were in school or perhaps in plus two, we will say between our friends, Arey, I also wrote the same answer. Teacher gave him 20 out of 20, gave me 18 out of 20. I have written the same thing. That is because perhaps the teacher is slightly biased to that person, he being a consistently better student, but it should not be like that. If I give more marks to one of your chairs because he topped in the first MBBS and second MBBS, then I am wrong. I am introducing bias. I am thinking that he is the best, but he is not, because there are others who are now coming up to his standard. Okay? So therefore, remember this word bias. Never ever have bias in your life. All friends are equal. I know some people are best friends, but then when it comes to the batch, everybody is same. You all belong to one batch. You are all, of a similar cohort. You are all of the same stock. So therefore, there is no bias. There should be no bias between you. Remember the word bias. Sources of controls, same thing, hospitals, general population, relatives, neighborhood, whatever. Okay? Now, some epidemiologists recommend different sources for cases and controls to avoid selection bias. I'll tell you what is selection bias in a while. Some people say, some workers say, select them from two different populations, their own thought. But up to you, you have a pool in hospital, relatives, neighborhood, and general population. Neighborhood, general population, almost the same. More than one study from different geographical areas are desirable to make the case control study a very strong one. Okay, all these are theoretically written in your book. They may not be possible for me and you at our level, but people who do a research, say like they are doing a research on the vaccine for COVID, they are doing studies in UK, they are doing studies in India. So different regions, they are doing some studies, and then they will find out which is the most, correct, method or correct vaccine or whatever. Now, matching. I told you this is a potential short no, but it is nothing but compatibility between cases and controls. Okay, we match. I have to match the color of my shirt with something. Okay, we go to a matching center, a process by which controls are selected in such a way that they are similar to cases with regard to certain pertinent selected variables known to influence outcome of disease. Suppose I study some disease in your class and I compare it with a school child who's in class 8. That is bias. We are not matched. Okay? The age factor will influence outcome. When you are 12 years old and when you are 20 years old, there are certain diseases which happen in 12-year-olds and certain diseases which don't happen in 12-year-olds. So we have to match. We have to match the age, we have to match the sex, we have to match the ethnic background and everything. Okay? So we have to match. In case you don't match, you confound the results. I am confounded. I am amazed. I am in doubt. So in case you don't match, you will confound the results because of variables which will become confounding factors. Please remember the words matching and confounding. I am sure with my shouting from this distance, you people now know the importance of this. And there are paragraphs given in your book. Underline the important lines from where I have picked up these lines and remember them, read them. Okay? Matching protects against unexpected strong association between the variables and the disease. I need not stress more. Now, what are the advantages and disadvantages of matching? May increase the precision of case control. The sampling process is easy to understand. If analyzed correctly, it provides reassurance that matched variables cannot explain the differences since we have matched. But what are the disadvantages? Could be time consuming. You have to find out from the population who are matched. Some potential cases and controls could be excluded because you are so bent up on matching, and matching variables cannot be evaluated. In case everything else is same other than one factor, you cannot study the other factors. So therefore, for studying 2-3 factors, you may also like to keep 2-3 factors which are different from one group and the other group. These are little complicated. We will stick with simple things like we have matched cases and comparable group or controls for everything except for the case, except for the disease we want to study. What is confounding factor? Again, a short note. I have repeated this, but I'll again read it for you. One which is associated both with exposure and disease, that is cases and that is exposure and disease, and is distributed unequally in both the groups. Okay, I've already told you this. That's why unequally is in yellow. Although associated with exposure under investigation, it itself, independently of any such association, is a risk factor for the disease. So we have to match for age, we have to match for addictions like smoking. You can't have two groups you are studying with one group non-smoker and one group smoker. You can have if you are studying the effects of smoking. But in case you are studying the disease per se, lung cancer or COPD, then both the groups have to be smoking ideally, and you got to find out why this group of smokers got COPD and why the other group did not get, though they are matched for everything. That is where we analyze. That is why analytical study. There are several kinds of matching. Group matching, we compare two groups and we match them, or in pairs. Suppose in my classroom, in two sides you are sitting. From this side, one person will be matched with the other person. The second person will be matched with the other person. The third person will be matched with the third person. So it is in pairs. We are matching in pairs. Or the easier method is, I'll say people sitting on my left, please stand up. People sitting on my right, please stand up. I'll see their general height, I'll ask their age, and I'll say sit down. So I have matched the two groups, which is a little, you can say, shortcut, okay, as compared to matching in pairs. If matching is overdone, it may be difficult to find controls, so please be very rational and do your matching at the earliest when you start a study. Now, measurement of exposure. How do you measure the exposure? I already told you it's a retrospective study. We go back in time. So therefore, we take interviews, we give questionnaires, we go for past records, case sheets and all that, hospital records, employment records. There are various ways to measure the exposure because we are doing a retrospective study. And how do you analyze? Well, here comes the important part, because you people have been taught all this, I guess, in your clinical postings. We have to find out the exposure rates among cases and controls, and we have to estimate the odds ratio or the risk associated with exposure. Remember, odds ratio for case control studies. Now, how do you find out exposure rates? It will become clear here. This is called as a 2 into 2 table. Please remember this. You must have already drawn this in your clinical postings. This is column A, B, C, D. It has to run in a Z fashion, Z fashion. Okay? Whenever you have cases and controls on top, you have smokers and non-smokers here. Okay? And you mash this should be more than 5 cigarettes, I think, not less than. Okay? And you build a table like this. Now, what is the exposure rate of cases? Now, these are the cases of exposure. Which people are exposed? These are the people who are the cases, A and C. Okay, these are the cases. And which are the smokers? A. So, exposure rates, that is, people who are exposed to smoking, are 33 by 35, 94.2%. And what are the exposure rates for controls? Among controls, these are the smokers. Okay? And this is the whole bunch, B plus D. So, includes the non-smokers. So, how many smokers out of the total group are in the control? So, exposure rates among control or people who are smoking among controls are 67%. Nothing great, simple mathematics. Frequency rate of carcinoma was higher among smokers than non-smokers. See, the frequency rate, the simple percentages are higher among cases than among controls. Statistical association has to be determined next. I told you we are here to prove that there is a statistical association and the strength of that association. Now, how do we do that? The statistical association can be resolved by calculating the p-value, which in this case is less than 0.001. Now, please remember, we must have taught you in biostats in the clinical postings, if P is less than 0.05, it is regarded as statistically significant. Okay, but it doesn't imply causation. It includes a strong association, but it doesn't say it causes. Please remember, these are a play of English words, nothing else. In this case, the p-value is less than 0.001, which is less than 0.05 and therefore statistically significant. Now, we come down to estimation of risk, which is the cross ratio, relative ratio, or risk ratio. This is relative risk is more important in cohort study, but we will just mention here incidence among exposed divided by incidence among non-exposed. So if you go by, this table, incidence among exposed is 33 divided by 88, okay? And incidence among non-exposed is 2 divided by 29. Yeah, A by A plus B and C by C plus D, and we divide that and we find out that the relative risk is 5.4. But just forget about it. It is just a formula I have given you. I'll again give it to you in cohort studies. What we are more interested in case control is the odds ratio or the cross product ratio. Remember, it's a cross product, X. So what is the cross product? If this is the 2 by 2 table that we have just described, AD divided by BC is the odds ratio. In this case, 33 into 27, okay? And 2 into 55 makes it 8.1. Odds ratio is a short note by itself. Odds ratio is a part of your answer to case control studies. Odds ratio is something which you will calculate in the clinical, in the epidemiological exercises that we will give you. Very important. And what is 8.1? 8.1 shows smokers have a risk of developing lung cancer 8.1 times more than non-smokers. We already said smokers are more than 5 cigarettes per day. So you can modify this by saying smokers of more than 5 cigarettes per day have a risk of developing lung cancer 8.1 times more than that of non-smokers. Now you know how we have analyzed. After we have got the data, we have interpreted the data in getting the exposure rates among cases, exposure rates among controls, and the odds ratio. These three define a case control study. Please remember that when you write a note on case control, you have to write about exposure rates, cases and controls, draw a fictitious 2 by 2 table, and also must mention odds ratio. Now, we come to bias. I already told you what is bias. How is bias defined? Any systematic error in the determination of association between exposure and disease. Any systematic error in the determination of association between exposure and disease leads to bias. Okay? It is systemic, non-random deviation of result. Why? Because you didn't match, you didn't compare. There was non-comparability between study and control groups. Now, what are the types of bias? Bias due to confounding, I have already explained this to you. Memory or recall bias, I am asking you, what did you eat 3 days ago? You don't remember. Or even if you remember out of 5 items, 2 items. So there is a recall bias. Selection bias, I told you about this. I am your sports teacher. I'll select some favorite students of mine. I will leave out the others and not even check their talent. So that is selection bias. It should not be like this. What is Bergsonian bias? I'll just tell you in a while. It is a bias due to the different rates of hospital admission. And there is interviewer's bias. When I'm asking you some questions, I ask some leading questions. Okay? And that itself is bias. So remember, bias is a short note, and you have to mention the types of bias after defining it. Now, there are various types of bias. In your book, they give you short paragraphs defining it. I have written them here, but I have also described you the different types of bias. Dr. Joseph Bergson described a type of bias which goes after his name. That is because of different rates of admission to hospitals for people with different diseases. Just mug this up. don't have to go into the depth of it, and write Bergsonian bias in your classification of 5 types of biases. What are the advantages and disadvantages of case control studies? Now, the advantages and disadvantages, please remember, they can be exchanged when it comes to cohort studies. Many a time you will get a question, please compare case control and cohort studies. So you have to remember this table, and you have to remember whatever comes this side will come this side in the cohort study. We will just describe cohort study next. Now, case control studies are easy to carry out. You just have to select some cases and controls and go back in time. You have to sit in a room like this and keep asking questions or go through records. It is rapid, less expensive, requires fewer subjects. There is no risk exposure to subjects because you are not intervening, you are not giving any drug, you are not introducing any vaccine or medicine. It allows the study of several different etiological factors. Risk factors can be identified. There is no attrition problems. What is attrition? In between studies, some people leave. Say that, sir, I'm not going to come from tomorrow because I've got some work. Okay, there is no attrition problem in case control studies. Whereas in cohort studies, since the studies go on for a long time, you lose certain people who leave the study because of various other reasons. It finds its major use in chronic diseases. Remember that, case control. Whereas the disadvantages of case control are there could be problems of bias, there could be problem of control group selection because it may take some time because you take some time to match. The incidence cannot be measured. I already told you that we can only estimate relative risk. We do not distinguish between causes and associated factors. Remember, very important, not useful for evaluation of therapy and prophylaxis because in that you have to give intervention. So what is important in cohort studies is not important in case control. In cohort studies, you give a medicine and you keep watching the patient over a period of time. So therefore, that is useful for evaluation of therapy and prophylaxis, whereas case control is not that useful. And major concern is that of representativeness of cases and controls, almost similar to this because we got to match both the cases and controls, which is a very, very difficult task. Now, it may sound very easy in a theory class when I am teaching you, but people who are on ground, who do the studies, for them it can be rather difficult. So we come down to cohort studies. The second important type of analytical study is the cohort study. Now, cohort study is also known by various other synonyms: prospective study, longitudinal study, incidence study, and forward-looking study. If you remember the synonyms, you will know that unlike case control, we have to now proceed from cause to effect, and not like effect to cause. So therefore, prospective, future looking, forward looking, cohort. This is a Viva question. What is a cohort? We will ask you. Don't look back at us blankly. You just say a group of people who share a common characteristic or experience within a defined time period. And they can be an age cohort, occupational cohort, we are all doctors, exposure to drug or vaccine, insured persons, we are all insured against a certain disease, or we have taken medical insurance. So we are a cohort of people with medical insurance. So therefore we belong to a particular group. Now, what are the distinguishing features of a cohort study? The cohorts are identified prior to the appearance of disease. We have to select normal people and intervene. Okay? The study groups so defined are observed over a period of time to determine the frequency of disease or the end result. The study proceeds from cause to effect. This will become clear in the subsequent slide. Now, what are the indications of a cohort study? Evidence of association between risk factor and disease needs to be established. The indications are the disadvantages of case control studies. When exposure is rare but incidence of disease is high, we told you in case control, see, we cannot study the incidence, but in case we want to study the incidence, we can resort to cohort studies. When attrition of study population can be minimized, we have to resort to cohort studies. We have to ensure that people don't leave the study. And of course, it's a costly affair because we introduce drugs, we follow these people up, We give them some incentive. Perhaps when they come to your lab for getting observed, you give them food and tea. So it's a costly study financially. General considerations: the cohorts must be free from disease. Both the groups should be equally susceptible to the disease. Again, matching. Both groups should be comparable. See, matching. The diagnostic and eligibility criteria of the disease must be defined beforehand, a thing which I have stressed in descriptive study, a thing which I have stressed in case control study. Now, this diagram will make it clear. We have got a group of smokers and we have got a group of non-smokers. We follow them over a period of time and see the outcome after 20 years. Now, in this group of smokers, you will find 1, 2, and 3 people getting cancer, okay? Whereas in this group of non-smokers, only 1 person was affected. Therefore, you are following over time from cause to effect, prospective. However, having stressed on the word prospective, there are 3 types of cohort studies: prospective, retrospective, and combination. That is, retrospective and prospective both. It may sound a little awkward. It may sound, why is he saying this? Because he just said retrospective is case control, but there are 3 types of cohort studies, though they are going back in time partially or fully, but they are still called as cohort studies. Why? In a prospective cohort study, the disease has not yet occurred at the time investigation begins. So there's nothing great in understanding a prospective cohort study. I just gave you the example, exposure, and then we finally measure the disease after a long period of time. In your book, there are various examples of cohort studies or prospective cohort study. One of the most important study which was done in the US is the Framingham study, which is still going on. And of course, we have a Doll and Hill study in UK by the Royal College of General Practitioners. These are very, very important studies. They are described in your book, but don't go through it. They are meant for PG level or whatever. You should know what to read and what to skip instead of clogging your mind. That is the prospective cohort study. We measure exposure and by making 2 groups, exposed and non-exposed, and then we observe them over a period of time. Now, what is retrospective cohort study? At the beginning of the retrospective cohort study, the investigator is aware of an exposure to a hazard that occurred at some time in the past. So therefore, see the difference. The disease has moved from here to here. If you see the diagram, the disease was here, it has now moved here, okay? So please remember this. The investigator is aware of an outcome somewhere in the past, and the cohort that includes the exposed individuals is identified and the health histories are taken, and again they are observed over a period of time. Occupational exposures, okay? I had pneumoconiosis. Why? Where did I work? So you have to take a cohort of people with pneumoconiosis and go back in time. Almost sounding similar to case control, but remember there is something called as retrospective cohort study, okay? And we do a retrospective analysis. This is the retrospective cohort study diagram. Okay, let's not waste our time in comparing. I told you the basics. And what is a combination study? A combination study is going into past records as well as following up the cohort for further outcome. Okay, it is somewhere which is a mixture of retrospective and prospective. Okay, so that is what is a retrospective prospective study. Now, what are the steps of a cohort study? I told you the 4 steps of a case control study. Here also the steps are 4 only. We can put analysis here and make it 4. Selection of study subjects, obtaining data, then comparing. Actually, selection of comparison groups should be second, but your book gives it as a 3rd point. Fine. Then you obtain data, then you follow up, you keep following up, and finally you analyze. The general population is from where we select the study subjects. They should be representative of the corresponding segments. Okay, we have already told you everything should be comparable. There cannot be 2 groups of people where you want to study only one factor and rest of the factors are unequal, then your study is biased. Okay, special groups, we can select doctors, we can select, like we have had some studies on COVID exposure in doctors. Okay, we have again special exposure to a physical, chemical, or other disease agents. That is also can be a type of special group. So you can have general population, you can select from a special group, and obtaining data on exposure, cohort members, we can review records. I told you retrospective. We can keep observing them with personal interviews or mailed questionnaires. We can do some medical examinations, and we can do some environmental surveys. So these are the 3 or 4 methods by which you obtain data. Selection of comparison, I told you there can be, it can be a second point, but then when you select comparable groups in cohort, there can be internal comparisons between the class, there can be external comparisons or comparison cohort, like I compare your batch with some other batch, or I compare your batch with general population. So please remember these examples. Internal means in your batch, I make 2 groups and compare. External means I compare your batch with some other batch. Comparison with general population is I compare your batch with the national standards or whatever. So these also have been explained in your book a little bit. But remember, when you write selection of comparisons, you won't have much time to explain. Just write these 3 points: internal comparisons, external, and comparison with general population rates. Now, what are the limiting factors of comparison with general population is non-availability of population rates. India is a country where if you go to the websites, you will find 2016 statistics being shown in 2020. So latest statistics are not available. Difficulties in selecting study and comparison groups can be also a problem from the general population. How do you follow up? We do a periodical medical exam. I already told you these things. We also do a review of physician and hospital records. We review death records. I explained to you the international death certificate. And of course, we nowadays email questionnaires, we make telephone calls, and we make some home visits, which is, of course, a little strict no-no now in COVID times. The groups are then followed over a period of time to determine the outcome of exposure. I have been telling you this in cohort studies. It's a repeat. And finally, we come down to the same 2x2 table for a framework of a cohort study. Like in case control, we have got a 2x2 table, and A, B, C, and D remain the same. Remember, this is the study cohort. This is the control cohort. In the study cohort, after following over a period of time, we find some people are diseased and some people are not diseased. In control cohort, we find similarly some people are diseased and some people are not diseased. And when it comes to analysis, like in case control, we now compare the incidence rates of outcome among exposed and non-exposed, and we estimate the risk. There we estimated risk, and we went on to the odds ratio, saying that smokers have 8.1 times more chances of getting lung cancer as compared to non-smokers. Now, how do you analyze a cohort study? Incidence is something which I have explained to you. It is the number of new cases occurring in a defined population during a specific period of time. I hope you have mugged up this definition. Okay, incidence rate among smokers and non-smokers are calculated in the following example like this. Incidence rate among smokers. Now, who are the smokers? These are the people who are smokers. Okay, these are the people who are smoking. And out of them, these people develop lung cancer. So 70 by 7,000, 10 per thousand is the incidence rate among smokers. Incidence rate among non-smokers. 3 non-smokers got lung cancer out of total 3,000. 2,997 didn't get. So 3 by 3,000, 1 per thousand. So incidence rate calculation among people who are exposed, 10. Among people who are non-exposed, 1 per thousand. Right? And as I have written here, A by A plus B, A by A plus B is more than B, C by C plus D. Here we estimate relative risk and attributable risk. Both are potential short notes. RR, AR. Time on these, shouting at you, shouting my voice through, because they are so important from the exam point of view. We have taught them in clinical posting, but perhaps without teaching you basic epidemiology, that was not correct. You didn't understand much of it. Now, relative risk is a ratio of incidence of the disease among exposed and incidence of disease among non-exposed. Nothing very great to remember. Incidence of disease among exposed divided by incidence of disease among non-exposed. In this example, incidence of disease among exposed 10, incidence of disease among non-exposed 1. So therefore 10 by 1 is equal to 10. And what does it say? It's a direct measure of the strength of association between suspected cause and effect. See how you are proving that people are more cancer than people who do not. You are measuring the strength of association directly. A relative risk of 1 indicates a no association, whereas a relative risk of more than 1 suggests positive association between exposure and disease. Here, the relative risk is more than 1. So there is a certain amount of truth, or you can say there is truth in the sentence that people who smoke are more liable to get lung cancer. The larger the RR, the greater the strength of association. Suppose in your example, you found RR to be 20. That is more than 10. So therefore, greater the strength of association between the suspected and factor and the disease. 20 is definitely more than 10. Now, just like RR, we have something called as AR, or attributable risk, okay, or risk difference. It is the difference in incidence rates of disease between an exposed group and a non-exposed group. This is the definition. Please define. When you get a short note, define. Relative risk is ratio of the incidence of disease among exposed and incidence of disease among non-exposed. Whereas attributable risk is difference. Okay, so therefore, incidence of disease rate among exposed minus incidence of disease rate among non-exposed divided by denominator is incidence rate among exposed. So this numerator becomes a denominator here, and this is expressed in percentage. Therefore, attributable risk in this example is 10 minus 1 divided by 10 is equal to 9 divided by 10 into 100, or 90%. Now, what is your conclusion? It indicates to what extent the disease under study can be attributed to the exposure, or the amount of disease that can be eliminated if the factor under study could be controlled or eliminated. Now, 90% of the disease can be perhaps eliminated if people don't smoke. This is your conclusion. Whereas in this, you have just said there is a association or a strong association between suspected cause and effect. Class, please appreciate the difference in conclusion when you find out relative risk and when you find out attributable risk. In your clinical posting, in that example, if you go back and see your notes, you will find we ask you to calculate relative risk and attributable risk and comment. Many of you calculate, write 10, write 90, and after that you keep quiet. You have to comment. What do you understand by 10? What do you understand by 90? And this is what you understand by 10 and 90. Direct measure of strength, and it indicates to what extent the disease under study can be attributed to the exposure. Okay? There is something called as PAR also, or population attributable risk. This is nothing but the word population has been added. In here, difference in incidence rates of disease between a group and non-exposed group. Okay, so group is the word. Whereas when it comes to population attributable risk, it becomes incidence of disease among in the total population minus the incidence of disease among those who are not exposed in the total population. So that's why the word population is prefixed, and it becomes population attributable risk. When you write a short note on attributable risk, you can add a small note on population attributable risk. Okay, we will not ask you to calculate PAR in your clinical, in your epidemiological exercises. We will only ask you to calculate relative risk and attributable risk. Now, what are the advantages of cohort study and the disadvantages of cohort study? I will not spend time on this. It is given in your book. Please remember, it is just the opposite than what we discussed in the previous table. The case control disadvantages become the advantages in cohort, and the disadvantages in case control become, the advantages in case control become the disadvantages in cohort study. It is more expensive. People leave the group. Attrition is there. Ethical problems are there. It involves a large number of people. It involves a lot of time and all that. So main differences between the case control and cohort studies is given in your book in the form of a table. There are 10 points there. There are 10 points there. Please read this table. I have already discussed what is there in each. I need not spell it out, repeat them and bore you. But there are 10 differences, and if you close your eyes and think whatever you have listened from me right now, you will be able to list out those differences. There is nothing, very, very important to mug up if you have understood what is case control and what is cohort study. It proceeds from effect to cause, cause to effect. Starts with the disease, starts with the people, not the disease. The disease has to happen in future. Tests whether the suspected cause occurs more frequently in those with the disease than among those without the disease. Tests whether the disease occurs more frequently in those exposed than in those not exposed. So, involves fewer people, large number of people. First approach is to test the hypothesis. First approach is to make the hypothesis in cohort study. Yields quick results, long follow-up, takes a lot of time, years. Suitable for study of rare diseases. It is not very suitable for rare diseases. Yields the odds ratio, yields the relative ratio, relative risk, and the attributable risk. Cannot yield information about diseases other than those selected for the study. In cohort study, you may be surprised to find some other conclusions in the end because you are going over a period of time. This is relatively inexpensive and this is relatively expensive. I will suggest that you remember this table, 10 points, and whenever the questions come about case control and cohort, from this table only you can get the advantages and disadvantages of a case control and cohort study. Sometimes a question has been asked as a part of a long question. Compare case control and cohort study. We will quickly rush through experimental study in the next 2 minutes. Experimental study means we are intervening, we are interfering. In modern usage, it is equated with randomized controlled trial. The Indian origin person Abhijit Banerjee, who got Nobel Prize last year with his French wife, has done so many randomized controlled trials in India on poverty. He got the Nobel Prize for economics. Okay, it is similar in approach to cohort studies. The intervention studies or the experimental studies are similar in approach to cohort studies, except that the conditions in which the study is carried out are under control of the investigator. You hold the reins. You want to introduce some intervention. It is up to you. In cohort studies, we can introduce a drug and then we have to wait. Here, you can stop, start, take out, you can do various kinds of intervention. That's why experimental studies are also called as intervention studies. James Lind gave, lime or introduced vitamin C, and he made people recover from some kind of illness which was later on called as scurvy. It's a very, very important experimental study. The aims are to provide scientific proof, a method of measuring effectiveness and efficiency in health services. We have to also keep cost, ethics, and feasibility in mind. Okay, there are two types, randomized and non-randomized. Randomized controlled trials means we randomize. We shake up the class and we say you go there, so we don't know who's where. We randomize. So this is one of the ways of reducing bias. Now please remember, RCT is basically a very, very important thing that some of you who may do research later on may also do. Drawing up a protocol, selecting a reference population, randomization, manipulation, we intervene, then we follow up, and finally we assess the outcome. These are the 6 steps. They are given in the form of an algorithm in your book, where we select a population, then we select a sample, then we make necessary exclusions. No, you are not suitable, you go. And then we randomize, we mix them up so that there are 2 groups or 3 groups which are all similar. And we have an experimental group like in cohort study, and we have a control group. And then we introduce the manipulation and follow up over a period of time to find the association. You will find this algorithm in your book. Whenever there's a question, please write the description, but also draw this table. Protocol is almost the same. I already described it to you. Aims and objectives of the study, define the disease. Selection of the population is from the target population or from the, it can be from the general population, all these things. Same steps like the previous one. Participants must give consent. You must take informed consent. Okay, they should be representative of the population to reduce bias. And we will learn about them in the chapter on statistics, and we make two groups, study and control groups. Okay. The essential difference between a RCT and analytical study is that in the latter, there is no randomization because of a differentiation into disease and non-disease groups. So therefore, in case control and cohort, we already defined diseased and non-diseased. This group has to be intervened and they will be diseased. This group has to be a control and they will be not diseased. Whereas in RCT, we have randomization. Then we manipulate when we introduce a drug or a vaccine whose effect has to be measured. We follow up over a period of time. There are some people who are lost to follow up. As I told you, this is called as attrition. And finally, we assess. Okay, we eliminate all kinds of bias, observer bias, evaluation bias, and all that. And we finally assess. Now, blinding can be done in three ways. When we do randomization, we do a single-blinded, double-blinded, or triple-blinded trial. In single-blinded trial, the participant is not aware whether it belongs to study group or control group. See, that is what is randomization. In double-blind, I also don't know who's in study group and who's in the control group, the investigator nor the participant. Whereas in a triple-blinded trial, the participant, the investigator, and the person analyzing the data are all unaware who belongs to which group. All this is to introduce impartiality. Please remember, I keep stressing today, for the last 1 hour, I've been stressing on important words like bias, confounding, and matching. Unless you do these things, you will not get a study with a proper association, with a proper hypothesis, with a proper, analysis that you can associate the strength, you can find out the strength of association. Now, there are various types of randomized control trials, clinical trials, preventive trials, and all that, risk factor trials, not very important from exam point of view, given in short paragraphs in the book, and cessation experiments. Okay, all these things are a part of randomized control trial. In non-randomized trials, we have uncontrolled trials, natural experiments, and before and after comparison studies. You can just go through them in the book. They have not been asked in the exam so far, but from the theory point of view, in case you want to complete an answer, suppose they tell you, define experimental epidemiology, describe randomized control trials. So to define experimental epidemiology, you also have to add that there are randomized and non-randomized trials. Randomized trials are basically RCT, and non-randomized trials are uncontrolled trials, natural experiments, and before and after comparison studies. There are various types. They are described in your book. I have got them written out here, but I don't want to spell out these slides because they will confuse you, right? So thanks, class, for concentrating. I know